All right, 4.4. When you have four terms, use factor by grouping. So in example 1, first of all, I don't have four terms here. I have two terms, but you should notice there's a GCF of x plus 4. So I'm going to pull the x plus 4 out of both terms, and I'm left with 2x minus 3. Now check your work when you factor. This is an x plus 4 times the 2x, and an x plus 4 times the minus 3. So it really does distribute back out. So in example 2, Elena, what's the GCF there?
Y minus 2.
Good, you should see a y minus 2, and then what's left is 3y squared plus 5. Okay? So, Noah, according to your blue paper, what is step 1 in factoring?
And always look for the GCF.
Okay, so in example 3, do we have a GCF among all four terms? No. All right, Jaslyn, what is step 2 in factoring?
Count the number of terms.
Count the number of terms. So we have 4 terms, and so Carmel, what do we do with 4 terms? What's it say on the paper?
Oh, sorry. Try to factor by grouping.
Try to factor by grouping. So let me refresh your memory from Algebra 1. To do factor by grouping, it's when you have 4 terms and there's no GCF across all 4. You look at the first 2 terms and pull out the GCF, just from the first 2 terms. You always write down the middle operation sign and then find the GCF of the next 2 terms, which happens to be a 5. What we're doing is we're creating a GCF like in example 1 and 2. So now I have an x plus 3, and what's left is x squared plus 5. Okay? All right, so Andrew, what is step 1 in factoring? The very top.
Always look for the GCF.
Okay, always look for a GCF. Do we have a GCF that I can pull out of all 4? No. All right, McKenna, what is step 2 in factoring?
Count the number of terms.
Count the number of terms. So then, Hannah, what do we do when there's 4 terms?
You have to factor by the grouping.
Factor by grouping. So we're going to pull out the first 2 terms, and the GCF is y. So I have y plus 1. Always write down the middle operation sign. You'll see y on the next 2. Then I pull out the GCF from the last 2 terms. It's an x. So now we have a common factor of y plus 1. Okay, so it's starting to come back to you from Algebra 1. Okay. All right, Henry, what is step 1 in factoring?
Always look for GCF.
Always look for the GCF. Then Elena, what is step 2?
It is count your number of terms.
Count the number of terms. And Noah, what do I do when I have 4 terms?
Factor by grouping.
Factor by grouping, okay? And I'm asking you guys this over and over and over again because by the end of the class period, we're going to know those steps, okay? So we're going to pull out the x, and we're going to get x squared plus 1. Now, do you remember what I told you? You always write down the middle operation sign, and then be very, very careful here. I want you to notice that when you factor out the middle operation sign and it's negative, why did I put a plus? Because the line above it's a minus. Why did I do that, Noah?
Because when you factor in, well, a negative times a negative is a positive.
Right, if I had put a minus here, I actually factored out the negative 4. Negative 4 times a negative 1 would be a plus 4, but I have a minus. So I've actually pulled a negative out, so it's flipping the signs, okay? Now I have an x squared plus 1, and what's left is x minus 4, okay? All right, Carmel, what is step 1 in factoring?
Always look for the GCF.
Okay, look for a GCF. There's no GCF across all 4 terms. Then Jaslyn, what is step 2 in factoring?
Count the number of terms.
Count the number of terms. We have 4. So McKenna, what do we use when there's 4 terms?
Factor by grouping.
Factor by grouping. So here we go. X squared times the quantity x plus 13. I always write down the middle operation sign. The GCF is a 5. Notice it's going to be the opposite sign. And let me give you just a helpful suggestion. If you're ever doing this, and one of them's x plus 13 and the second one is, did I say x? Okay, I meant if it's a plus 13 and I have a minus 13, you made a mistake. You forgot your minus sign and flipped, okay? These should be the same. So then my common factor is a plus 13, a squared minus 5. And let me pause here a moment. I've been maybe going a little bit too quickly here. You can check your work when you factor. A times a squared is a cubed. The outer is a minus 5a. There it is. The inner is a plus 13a squared. 13 times minus 5 is minus 65. It does check. And we really should be checking. All right. So now we're going to help Carmel with what she did last night. If you have ax squared plus bx plus c, we're going to use what's called the AC method. Well, I'm actually going to show you trial and error as well, but for several of you, you might like the AC method. Now, the A is coming from this A, from ax squared, and the C is coming from this C. So what you want to do is you're going to multiply the A times the C, and you want it to add up to the B value, okay? And what's going to happen is, and this is the beautiful connection to factor by grouping. What we're doing is we're trying to take minus 6w and break it into the perfect pair to turn it into factor by grouping. But here's how you do it. So I take 5 times 1 is 5, and I need it to add up to negative 6. So you have to have some number sense. If I have two numbers that multiply together that are positive, but add up to a negative number, they're both negative, right? And so the only options here are to take negative 1 times a negative 5. That multiplies to positive 5. But when I add them, it's giving me negative 6. So watch what we're going to do. We're going to take the 6w and break it into minus 1w minus 5w plus 1. And so every line has to be equivalent to the line above it. So look, minus 1w minus 5w, in fact, is equal to this line above, negative 6w. Then look, I created 4 terms, and I know how to do this. So I'm going to do factor by grouping. Now, you always write down the middle operation sign. Well, 5w and 1 really don't have anything in common except a 1. So you do need to put the 1 out front. And because the middle operation sign was a minus, it flipped this one. Okay? So now I have 5w minus 1 times w minus 1. Bless you.
Thank you.
So you guys be careful. If the last two terms have nothing in common, you do need to put the 1. Now let's check our work when we factor. 5w times w is 5w squared. My outer is minus 5w plus the inner, minus 1w, that's minus 6w. Negative 1 times negative 1 is 1. Yeah.
So it's basically like what we did on those, where because when it's 1 and you multiply by the outside,
Yes.
it's the same.
It is. So what we did on our warm-up today, so like x squared plus 9x plus 18, we really are doing 1 times 18. Do you see that? It is the exact same thing.
Is there a chart you can do, for the...
This is the chart, yeah.
Well, like, after you get the two numbers, like, wasn't it like opposites? From Algebra 1, it misses really, like, with the chart.
Yeah.
Okay.
I think I know what you mean. So look, in example 8, you would take 4 times 5 is 20, and I want it to add up to 9. So you know they're positive, so here's another way to kind of make your chart. 1 times 20, but that adds up to 21, so that didn't work. 2 times 10 adds up to 12, that doesn't work. But 5 times 4 adds up to 9. Like, you don't have to make the list if you can tell what it is. But only one pair works. You can't do this two different ways. So what I'm going to do is I'm going to rewrite the middle term as 5m plus 4m. So let me restate it just to make sure as we're moving through this. The purpose of the AC method is to rewrite the middle term into two terms so we can factor by grouping. Okay, that's the purpose. Is this the chart you were thinking, or were you doing, I know some teachers show where you're doing trials.
Yes, I think that's
Okay.
it. The four squares, you separate it into four squares and like one side's opposite.
I don't know what
I
that
think
is.
Okay.
I kind of remember what you're talking about, but I couldn't.
Are you
find
sure
it.
that's not multiplying them out instead of factoring?
I don't know.
I think, I know the box for when you're multiply binomial and binomial stuff. I can ask her.
Maybe I'm confusing them.
Okay, so let's factor by grouping. You always write down the middle operation sign. So you're getting 4m plus 5 times m plus 1. And you want to check your work when you factor. Now I'm going to go back through and do this with a method called trial and error. And some of you will be able to do trial and error, and some of you it might be just a little bit too much, and that's okay. You have the AC method. If you intend to go on to pre-calculus, I'd like to strongly recommend you get the hang of trial and error because it's faster, but you have to have really good number sense to do this. So here's trial and error. You don't have to write this down, just sort of watch me. What you're going to do is similar to what we did in yesterday's lesson, except, okay, for 5w squared, you know the only way to get 5w squared is 5w times w, right? The only way to get a 1 is 1 times 1. Because it ends in a plus, these have to be the same. Now check it. 5w times w is 5w squared. The outer is minus 5w, the inner is minus 1w. That's minus 6w. Negative 1 times negative 1 is 1. I got it like that. Now, when I go to do example 8, okay, so if I'm going to do example 8 with trial and error, when I go to do this one, and this is what I thought you were referring to, Noah, but I don't think so then. To get 4m squared, that's either 4m times m or 2m times, 2m, sorry. Okay, so then I have two ways to get my 5. I either make it 5 times 1 or 5 times 1. But you have to try both of them. And so you would have, if I do the bottom row, that's 4m plus 5m, that's 9m, I got it. If I try the other way, that's 20m plus 1m, that's 21. So then I don't even need to try this one because I got it pretty quickly. Okay, so then I have to consider my signs, and they're both pluses. Now, because I've been factoring a long time, I do trial and error, and I can do it very quickly now. So it is something that you need to mess around with to see if you can do it that way. So here's what I'd like to do is give you a moment. In example 9 and 10, I want you to try both of those, and you choose. If you think you sort of get trial and error, go for it. If not, do the AC method. do example 9, AC method, but I'm gonna do 10, trial and error. In 9, you're gonna take 6 times negative 4, 8 times c, okay, from ax squared plus bx plus c. So I'm looking for a product of negative 24, but adds up to negative 5. So I know it has to be one of each. So I'm going to get 6y squared minus 8y plus 3y minus 4. Now, somebody had asked in my other class, they put the 3y first and the minus 8y. That is absolutely fine. The middle of our work will look different, but our final answers will be the same. So it doesn't matter. So in either order, you need 3y minus 4 times a 2y plus 1. Okay, did you guys get that? Yes, okay. In 10, I'm going to do this trial and error. And watch. You know 3x and x are the only possibility. And so think about it. If I put the 7 and the 1, I kind of do it in my head. If I put a 7 and a 1, that's 7x plus 3x is 10x. But if I switch it, 21x and 1x, that can give me a 20x. And I need the 21 to be positive. So when I say check your work when you factor, you really need to be doing that. Because if you have your signs mixed up, you'll catch it in your check. And then you just erase and switch your signs. Okay? All right, any questions now on these? It does take a lot of practice to do, so that's why you notice more problems. Monday, we're going to be spending a second day on 4.4. I'm going to go nice and slowly through this because you have to be able to factor and factor well. Yeah?
So it doesn't matter if you have those two switched?
No, it does not, because remember, A times B is the same as B times A. All right, solving equations. We're going to write down some steps. Step 1, get everything on one side. Of the equation equal to 0. Step 2, factor completely. Step 3, use the zero factor property that we reviewed yesterday and set each factor containing a variable equal to 0. And step 4 is solve each of those resulting equations. So again, step 1, get everything on one side of the equation equal to 0. Step 2, you're going to factor completely. Step 3, use the zero factor property and set each factor containing a variable equal to 0. And then step 4 is solve it. So let's look at example 11. I have 3x squared plus 10x minus 8 equals 0. So let's do the AC method on this one, because I've already got step 1 is done, right? Everything's on one side equal to 0. Step 2 is factor completely. 3 times negative 8 is negative 24. And I want it to add up to 10. So you have to stop and think. To get a negative 24, one number was positive and one number was negative. And I need the bigger number to be positive, right? So I can think of this right away. 12 times negative 2 is negative 24, but that adds up to 10. So I'm going to get 3x squared plus 12x minus 2x minus 8. So I'm going to factor by grouping. Now when you're solving an equation, don't lose the equal 0. I have seen students who like drop it for a while and then at the end put it back in. That's technically incorrect, okay? You have to go an equation all the way down. So check your paper and make sure you have equals 0. Now this is just like what we worked on yesterday. The zero factor property says once you have A times B equals 0, A is 0 or B is 0. In our case, it's x plus 4 equals 0 or 3x minus 2 equals 0. So I subtract the 4 and then I add 2 and divide by 3.
This is my theory.
Yes.
For like the two parentheses, does it matter which order they're in?
Mm-mm.
Okay.
No, you could have 3x minus 2 times x plus 4, but you can't have the sign switched.
Yeah.
I can't have an x minus 4.
Yeah, because I did the trial and error thing and they're switched.
And that's okay. Yeah, that's absolutely fine. Okay, example 12. Step 1. Get everything on one side equal to 0. So we need to subtract 4p and add 5. So I'm getting 5p squared minus 20p plus 20 equals 0. Alright, now, what is step 1 in factoring?
Find GCF.
Find the GCF. This is the most common mistake I see. We're going to just get into motoring along our process and stop thinking. So please remember, step 1, look for the GCF. Now, p squared minus 4p plus 4, notice that really is a 1 in front of the p squared now. It's a perfect square trinomial, isn't it? That's p minus 2, the quantity squared. Now I want to point something out in my steps, in my step 3. Look at step 3 with me. It says use zero factor property and set each factor containing a variable equal to 0. So I'm not going to set 5 equal to 0, and let me explain why you don't do anything with just a constant. If I divide both sides by 5 because it's an equation, you still get equals 0. So I don't really have to divide by 5, but when you use the zero factor property, you don't ever use that just a constant, okay? So then we're going to set p minus 2 equals 0 and p equals 2. And something I want to point out to you, because you're like, well, wait a minute. In example 11, we had 2 answers, and here I only have 1 answer. And let's make a connection to the graph. At p equals 2, do you remember a solution is the x-intercept, okay? The solution, sometimes it's called a 0. We talked about it yesterday. So this opens up because it's a positive 5p squared. So it opens up, but this is only touching once. And if I come back over to example 11, let's make a nice connection to our graph. I have an x-intercept at -4 and at positive 2/3, it opens up. I don't know exactly where the vertex is, but I at least know it's somewhere in between them, right? And don't we know that it's exactly halfway between when you have 2 x-intercepts? Because that leads me to the next idea here. To find the maximum and minimum value of a quadratic function, you can first use factoring to put it in intercept form. Y equals a quantity x minus p times x minus q. And because the function's vertex lies on the axis of symmetry, it's going to be the minimum or maximums at the vertex. Okay, we know that. So let's look at the last example, and I did have an example 13, and instead of renumbering, I just deleted it. So I really do know how to count. This says example 14. It says find the zeros of the function by rewriting the function in intercept form. It's very important that you understand that the word zeros means x-intercept on a graph. And to find an x-intercept on a graph, you let y equal 0. So that's why it's called a 0. So in letter A, g of x equals 3x squared minus 8x plus 5. If you want to find the zeros, you just replace the y value, or g of x, with 0. And then let's try trial and error on this one. To get 3x squared, you'd have a 3x and an x. Well, there's only two numbers that multiply to 5, but we need to figure out, is it 1 and 5 or 5 and 1? If I put the 1 and the 5, I have a 15x and a 1x. That's not going to produce an 8. So let me erase it. And we're going to make it 5 and 1. 3x, 5x, that's going to work for me. And because I want a negative 8x and I want a positive 5, they're both minus signs. Then I use the zero factor property and set each factor that contains a variable equal to 0. So I'm getting x equals 1 or x equals 5/3. Alright, last one. Y equals 3x squared minus 3x. We're going to set it equal to 0. Now what is step 1 in factoring? GCF. I will tell you, this is going to be what's going to trip us up the most often. There is a GCF. And then you're going to set each factor. Now 3x does have an x to it. Okay, so we're going to set 3x equals 0 or the x minus 1 equals 0.